This problem is from GATE 2020 Mechanical Engineering Offset 1. The question is, the velocity field of an incompressible flow in a Cartesian system is represented by V vector is equal to 2 multiplied by x square minus y square I cap plus V j cap plus 3 k cap. Which of the following for V is valid? Now we are given 4 options here and we need to find the value of V. That is the velocity of flow in the y direction. The differential form of continuity equation can be written as dou by dou t of rho, that is partial derivative of rho with respect to time, plus del dot rho v vector, and this is equal to 0. Now since in the problem it is given that the flow is incompressible, that means the density won't change either with respect to time or with respect to space. So this right here, the partial derivative of density with respect to time will be equal to 0. Now since density is constant here, we can take the density outside and we can write rho del dot v vector is equal to 0. Also this can be written as del dot v vector is equal to 0. Let this be equation number 1, and this is the continuity equation for incompressible flow, that is given by divergence of velocity vector is equal to 0. Now the divergence of any vector field, suppose f vector is equal to fx I cap plus fy j cap plus fz k cap. Now the divergence of this vector del dot f vector can be written as dou by dou x f of x plus partial derivative of fy with respect to y plus partial derivative of f of z with respect to z. Now important thing to notice here is that the divergence of a vector is a scalar quantity. So if you take the divergence of any vector field, it will become a scalar quantity. Now let this be equation number 2. For this problem, velocity vector is given as 2 into x square minus y square I cap plus v j cap plus 3 k cap. Now let this be equation number 3. Now from here you can see that 2x square minus y square is u, that is velocity in x direction, v the velocity in y direction, and 3 is w, the velocity in z direction. Now you can pause the video here, and with the given information and the concept explained for incompressible fluid flow, you can solve and try to find the answer. Coming back to the problem, del dot v, that is divergence of velocity vector, can be written as dou by dou x of u plus dou by dou y of v plus dou by dou z of w. So now let's substitute the value of u, v, w from equation number 3. So we have dou by dou x of 2 x square minus y square plus dou by dou y of v. V will remain as it is because the value of v is not given, which actually we need to find out, plus dou by dou z of 3, and this divergence of velocity vector must be equal to 0. So from here we can see, now if you differentiate this first term with respect to x, you will get 2 into 2 times of x. Since y is treated as constant, so differentiation of y will become 0, plus the derivative of dou by dou y of v plus the differentiation of constant is 0, so this will remain 0 equal to 0. Now solving this equation, we will get 4x is equal to minus dou v by dou y Now let's multiply dy both sides. We will get 4x dy is equal to minus dou v by dou y into dy. Now we can integrate this equation. So integrating both sides, we can write like this. So what we will get from here, this will be 4xy, because we are integrating here with respect to y. Now here we will get minus v plus a constant. Now let's rearrange this equation. So rearranging, we can write it like that. V is equal to minus 4xy plus k. Now k is some minus c from this equation. So you can just use c here as well, because we actually don't know the value of constant. But here we know that k must be the function of x and z. So this constant must be the function of x and z. Why? Because we have taken a 3D equation and we have integrated with respect to y. So the constant will be the function of the other two dimensions, that is x and z. Now let's match with our given options here. Since we don't have any other conditions given in the question, we can match our answer and we can check with the solutions. So we have got minus, we have got the value of v as minus 4xy plus function of x and z. So there is only one option here, that is option B, which has x and z. So option B must be the correct answer. For more information on continuity equation, you can follow the NPTEL course of convective heat transfer by Dr. Arvind Pattamata and Professor Ajit K. Kolar of the Department of Mechanical Engineering, IIT Madras. Hopefully I was able to solve your doubt. Have a great day. Thank you.